Before we begin, subscribe my channel for future updates. So today's topic is Newton's laws of motion. Newton's laws of motion. Now states that first law of Newton's states that an object continues to be in a state of rest or uniform motion along a straight line unless acted upon by an unbalanced force. Means if there is an object A, if it remains at rest, then it will remain at rest. If it moves from the point A to some other point B, point C, point other, then this means uniform motion. It goes in a uniform motion along a straight line. If unbalanced force act on it, then it will move. If it remains at rest, then it is called inertia. If an object remains at rest, then it is called inertia of rest. If an object is moving, means it is moving with inertia of direction along a straight line. Imagine if this is a xy plane, xyz plane. If there is an object, it will remain in a state of rest. If it moves, it have tendency to move along a straight line, along x-axis, along y-axis, and along z-axis. I will show you some illustration in order to justify first law of motion. I have taken this box, a cardboard, and a 5 rupee coin. What happens? You see, I place the box as it is, I place the card, and I place the coin over it. Imagine if this is an object, if it is remains in a rest, then this is called inertia of rest. If I move this card, what happens? You see, now the coin goes inside because of inertia of direction. This is called inertia, means tendency of an object to resist a change in its state of rest or uniform motion along a straight line. Another example, I have taken water inside this glass. What I do, you just observe. I place a card over it and I place a 5 rupee coin over it. What happens? You just see. If I move this card, then it goes to any direction. You just observe. It goes inside. This is called inertia of direction. If an object is at rest, it remains at rest. If an object is in motion, it goes along a straight line, along x-axis, along y-axis, and along z-axis. This is called inertia of direction. An object remains at rest means it is inertia of rest. This is a carom board. I have placed coins on it, and this is a striker. Now all the coins are remains at rest, means it is inertia of rest. If I hit these coins to any direction, along x-axis, along y-axis, along z-axis, then it moves. You just observe. Except this coins moves forward, and this will remain at rest. This is due to inertia of rest, and this is due to inertia of direction. So Newton's first law of motion states that an object continues to be in a state of rest or uniform motion along a straight line unless acted upon by an unbalanced force. And inertia means tendency of an object to resist a change in a state of rest or uniform motion along a straight line. For example, if this is a car, if this is placed along x-axis, it is in inertia of rest. If I move this, it goes to any direction. I will move. This is due to inertia of direction. Because I acted unbalanced, I act in the car as unbalanced force. And Newton's second law of motion is the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. Rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Momentum means product of mass and velocity. Product of mass and velocity. P is equal to m into v. P means momentum. P means momentum. Momentum is equal to momentum is the product of mass and velocity. Rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. I will explain this by giving examples. Now observe this balloon. I blow air inside this balloon. What happens? You just observe. I have blown air inside this balloon. With the initial velocity of the air inside this balloon is u, and I don't know what is the mass inside, so I take as it is m. P1 is equal to m into u. If I release, the velocity of the air will increase, and I take velocity of air inside this balloon is m into v2. Now next observe what happens. All the air will goes out, so I take the velocity v2, initial velocity u, because it remains at rest. When I release, it is in motion, so v2. Another example, if this is a car, initial velocity u, and this is a car, I have moved it with initial velocity v2. What happens? You just observe. The car will move with the velocity v2, means initial momentum is m into u, final momentum is m into v2. So change in momentum is equal to m into p2 minus p1, that is equal to m into v minus u. This is v minus u. Rate of change in momentum is given by m into v minus u divided by t. Rate of change in momentum is m into v minus u by t. If we solve this equation, it gives you the formula of force F is equal to m into a. Acceleration means v minus u divided by t, and m in the mass in kg, and F is the force. SI unit of force is Newton, and SI unit of momentum is kg meter per second. SI unit of mass is kg, and acceleration is meter per second. So hence SI unit of momentum will be kg meter per second, and SI unit of force will be kg meter per second square. Instead of that, we write as Newton, N. Next we move on to third law. Newton's third law of motion says that to every action there is an equal and opposite reaction, and they act on two different bodies. Means if there are two cars coming along this side, if there is another car coming along this side, if I hit this another car, what happens? You just observe. The another car will goes in opposite direction, because to every reaction there is an equal and opposite reaction, and they act on two different bodies. If we hit a wall with our foot, what happens? You just observe. If we beat to the wall with our hands, what happens? You just observe. For every reaction there is an equal and opposite reaction. If there is a car moving and hit this car, means it is action. This car acting force on this car, and the reaction, what happens is this car move along this side, so this is reaction. This is action, and this is reaction. This gives an alternate statement that for every action there is an equal and opposite reaction. Action, reaction act on two different bodies, and this is nothing but third law of motion. Thank you friends for watching this video.